Welcome to The Explainer. Today, we're diving into a fundamental shift in computing, all driven by NVIDIA's latest roadmap. And this isn't just a small step up. We're talking about a change so massive that it's turning data centers into something totally new, AI factories. So let's break down what that actually means. Okay, so to really get what NVIDIA is up to, we first have to understand the new challenge that AI is facing, because the whole game is changing and fast. We're moving way beyond AI that just creates stuff to something, well, something much, much smarter. Yeah, we're talking about agentic AI. This is AI that can really think, plan, and act all on its own. So imagine you give an AI a complex goal. It doesn't just give you one answer. It breaks the problem down, it uses tools like a web browser or a code interpreter, it looks at the results, and then it does that whole cycle again and again until the job is done. So what's the catch? What's the big hurdle for an AI that can actually think like that? See, this whole multi-step process creates a completely new bottleneck that changes everything. It's not just about raw power anymore. The real value, the thing that makes or breaks these systems, is all about their speed of thought. And it all boils down to this one idea: time to thought. Every single step in that thinking process is like a new thought, a new inference. So the value of these AI agents depends entirely on how fast they can get through that whole chain of thoughts. A system that takes minutes to think, it's pretty much useless. But one that takes seconds, that's absolutely revolutionary. Suddenly, latency is the new enemy. So how is NVIDIA supposed to solve this time-to-thought problem? Well, meet their answer: the Blackwell architecture. And let me be clear, this is not just an incremental update. This is a total ground-up redesign, built specifically to attack this one massive bottleneck. The real breakthrough here is something called FP4. It's a new super low precision format, so instead of using 16 bits to represent a number, it uses just 4. What does that mean? It means the data the AI needs for each thought gets dramatically smaller. Less data to move, less data to store, which all translates directly into way faster computation. And the result of this? It's huge. We're looking at a 9 to 10 times improvement in throughput over the last generation. That is a direct speed up of the AI's thinking process, making real-time, complex reasoning a reality for the very first time. And here's the crucial point. This isn't some happy accident. Features like the new FP4 support, they're a purpose-built weapon for this new era of AI. NVIDIA saw the time-to-thought problem and engineered a direct solution for it. Okay, so this new power is amazing, but there's a huge consequence, and it's forcing us to completely rethink the data center as we know it. We are entering a brand new world for how we build and run our computing infrastructure. You see, we're not thinking about individual servers anymore. That's old news. The new unit of compute is the entire rack. A system like the NVL72 connects 72 GPUs together with super fast networking, making them all act like one gigantic single GPU. The rack is the computer now. Now, this is where things get a little crazy. Just look at the power density. A traditional server rack might pull around 10 kilowatts, but a single Blackwell rack, we're talking 120 kilowatts. That is more than a tenfold jump in power and heat in the exact same physical space. So what does that massive power jump mean? Well, for one thing, you can forget about air conditioning. At these power levels, there is just no way to get that much heat out with air. Direct liquid cooling isn't a nice-to-have option anymore. It's mandatory. It's a facility-level requirement. This is no longer an IT problem. It's a huge facilities engineering project. And this trend of more power, more integration, it's not slowing down, not even a little bit. In fact, NVIDIA's roadmap shows it's about to accelerate. So let's look ahead to the next chapter. Rubin. NVIDIA has officially switched to what they're calling a one-year rhythm. This just completely destroys the old way of doing things. You know, that traditional 3 to 5 year server refresh cycle, yeah, that's ancient history now. To stay on the cutting edge, you have to plan for constant, rolling upgrades. And this table, wow. It really shows you the insane leap we're about to take. I mean, look at that Rubin Ultra column. A terabyte of memory per package, a more than 3x jump in performance. But honestly, the most shocking number is right there at the bottom. 600 kilowatts.
let that just sink in for a second. That's the projected power for a single Rubin Ultra rack in 2027. To put that in perspective, that's 50 to 60 times the power of a traditional data center rack. This is a step change that has absolutely massive implications.
You just can't walk into an existing data center and plug a 600 kilowatt rack in. No way. The power and cooling infrastructure just isn't there. This level of power means the chip, the rack, and the entire data center facility have to be designed together, from the ground up, starting all the way back at the electrical substation.
So what does this all mean for you? For anyone trying to stay in the game? Well, this isn't a simple hardware upgrade anymore. It's a fundamental shift in strategy. Being competitive in the age of AI means you need a whole new playbook.
So let's just recap the new rules of the road. First, the rack is the new server. Second, liquid cooling is absolutely mandatory. Third, that one-year rhythm means you need to plan for constant upgrades. Fourth, your biggest limitation isn't compute anymore, it's power. And finally, you have to co-design your IT and your facilities. To succeed, you have to transform your data center into a true AI factory. And look, this isn't some far-off sci-fi future we're talking about. This shift is happening right now. The organizations that get this, the ones that embrace this new reality and start treating their data centers like factories, they're going to be the ones who lead the next wave of innovation. The only real question left is, will you be one of them?